Now, struggling with systems of equations, this is a common problem. We did a video last week, linked in the down below, where we were talking about solving systems of equation by substitution. That's one method, and sometimes it's a messy method to people. So we'll look at the second method, or a second method, which is elimination, which is also popular. I like substitution better. Elimination sometimes just pops out as the easiest way to do it. So what we have here in front of us is two equations, 3x plus 2y equals 16 and 5x minus 2y is equal to 4. So in elimination, what we're doing is basically, can we add or subtract, I'm going to say, can we add or subtract these two equations together to end up with another equation? That sounds maybe a little weird. I mean, the first time I heard that, I'm like, that doesn't make sense. But what we're looking for is we want to eliminate the x or the y. And so the trick we're going to do on this first one is, we notice that this has a plus 2y right there, and this one has a minus 2y. So what I can do is, I'm just going to do this, I'll do this two different ways, but is I can just add, I'm going to just put these things together, and I'm going to add these two equations together, and you should see what I mean. So if I take the 3x plus the 5x, that's going to give me 8x. The 2y minus 2y, so that's plus and minus, that's going to give me plus 0. And then I have 16 plus 4 is going to give me 20. And so the answer there is going to, or it's going to give me 8x is equal to 20. So that's how we're going through this process. So if I divide this through, I'm going to get x equals 2.5. And there's my first solution, which is the x value. So now with that x value, and remember what we're doing here is we are solving two equations, right? And I'll just pretend they look like that. And I'm looking for where these two equations, that's equation A and that's equation B. Not really, I'm just making this up because they may not look like this. But I'm looking for the point where they intersect. That's the solution, is where these two equations intersect. So what I'm now giving is x is equal to 2.5. So that gives me this is 2.5 right there where they intersect. Okay, so now I'm going to take the 2.5 and plug it back into one of the other equations. I'm going to take the first equation, so it's a 3x plus 2y is equal to 16. I'm now going to plug this x in there, and it's going to give me 3 times 2.5 plus 2y is equal to 16. Now 3 times 2.5 is going to give me 7.5. That should be x right there. 7.5x. I'm sorry, that should not be x. I told you just wrong there. That was a silly mistake. The x is what we just stuck in. All right, so there is the x is the actual x value is gone. So it's 2.5. So it's 7. So we stuck the x in. It's 2.5 times 3. So it's 3 times 2.5 is 7.5 plus 2y is equal to 16. Now I'm just going to do the math. I'm going to subtract 7.5 on each side. So that's going to give me, or from each side, that's going to give me 2y is equal to 8.5, and therefore y is going to be equal to, take 8.5 and divide it by 2. I mean, you can do this in your head, but if you're using a calculator, is 4.25. So that's going to be this value, is the y, is 4.25. So that would be the solution to the equation. Now there's another way you can solve this, and just come over here real quick and say, if I start over here in the first step and say, could I solve this differently? Maybe you don't like adding it together the way I did right here. To me, that's the easiest thing to see. But some people might say, well, what I'm going to do is say 3x plus 2y plus 5x minus 2y equal to 16 plus 4. And basically I added those two equations together, and really I'm just now saying 3x plus 5x, bring like terms together, plus 2y minus 2y. Okay, then is equal to 20. We'll go ahead and add that together. So that would give me the same result. If I solve that out, I'm going to get the same thing. I like doing it just this particular way. If I look at Harold Jacobs, the way he does this in his textbook, I think it's chapter 7 of simultaneous equations. Let's actually look. Yes, chapter 7 of simultaneous equations. You will also see this in Harold Jacobs' geometry, in the algebra review at the later part, and you will also see this in chapter 2 of the algebra 2 and trig. Same thing repeated over. So this is simultaneous equations by elimination. Now you may say, hey, I've done this before, but I don't. This 2y and this 2y that I'm seeing here isn't always so pretty. It's not always lined up like that. So let's look at a more complicated example, which is after you get past the first part, that's kind of what happens. They're not always that clean. So let's just give you another one. Let's say we have, that's not what I meant to say. Let's say we have a problem that's got something like 2x plus 3y equals to 7. I am trying to write slow because I write sloppy, and my team tells me this stuff is sloppy. So hopefully you can read it, but I'm trying to do better. It's 5x minus 2y is equal to 8. All right, so now what we notice is there is the two x's. It's not a 5 and a 5, and for the y's, it's not a 3 and a 3 or 2 and a 2. So I can't just add these together and get what I want. So whenever you see this, what we're looking for is how can I add or subtract these two equations? And you can do anything. You can either add or subtract these two equations together. But the one hint is this one's a plus. This top one is a plus right there, and this one is a minus. So what I could do is say, what's the least common multiplier between this 3 and this 2? And that's just going to be 6. 3 times 2 is 6. So how do I turn this into 6? Because if they were both 6, then they would both go away. So what we would do is take this first equation and multiply the whole equation by 2, because now 2 times 3 is 6, and multiply the second whole equation by 3. And remember, if I take an equation and multiply or add or do anything to both sides of the equation, as long as I'm doing it to both sides, they're still going to be equal. So if I multiply the first side by 2. So let's just bring this down. So that's going to give me, the first equation becomes 4x plus 6y is equal to 14. So there is the first equation. So that's that one right there, and it's multiplied the first equation by 2. So notice I got my 6y. That's what I'm after. And now let's multiply the second equation by 3. And that's going to give me 15x minus 6y. That's the part I'm looking for. And then 8 times 3 is 24. So now the equation looks kind of like the other one, right? I've got a 6y here. And right there, and a plus 6y and a minus 6y. Now I'm going to add these two equations together, and the 4x plus the 15x is going to give me 19x. The 6y and minus 6y becomes 0. And then the 14 and 24 is going to give me 38. All right, so now what I've got is 19x equals 38, and so that's going to give me, if I divide by 3, that's going to give me x is equal to 2. Okay, so there's my solution to this equation for the x value. Now, just like before, I take the 2 and I plug it back into one of these equations. Now, the solution works. It doesn't matter if I multiply that 2, put that back into this equation right here, this equation here, or one of these two top original equations. And I'm going to go to the original ones because the numbers are smaller, and that usually is the case. Because they're all the same. The two top equations are the same, and the two bottom equations are the same. So and anywhere you put this, it would work. I'm going to go over and say, well, let's just say it's 2. Let's go to the 2x plus 3y equals 7 equation, and then plug in the x value. So that's going to be 2 times 3 plus 3y is equal to 7. That's 6 plus 3y is equal to 7. All right, so now what I'm going to do is subtract these. All right, let's see if I'm... No, I did that. I knew something didn't look right. I'm plugging in the wrong number. So this is the day of errors. All right, we always have errors when we're doing this, and we have to look and say, does that look right? So no, the x was not 3. The x was, in fact, 2. So I put that in there wrong. So now that should be 4 plus 3y is equal to 7. So now I subtract 4 from each side, and that's going to give me 3y is equal to 3, which is going to give me y is equal to 1. And so now I could plug both of these numbers back in this second equation, and this is, remember, on simultaneous equations, you know you have the right answer. If I plug this x equal 2 and y equal 1 into the second equation, it's all going to work out, and it's and so you could just quickly say, well, that's well, let's just do it. So the first equation, I'm going to plug in the x value, which is 2, and the minus 2 times the y value, which is 1, and equals 8. So that gives me 10 minus 2 equals 8, and that checks. And that's one thing you can always do with simultaneous equations to make sure that it works properly. So this is the second method of doing this. Now, these are just tools in a toolbox. This is simultaneous equations. Last time we did substitution. This time we're doing elimination. And we're just manipulating and they get algebra equations in ways that we're allowed to do by the rules of algebra. And so this isn't magic. This is just tools in a toolbox, as I like to call this. So they're methodologies that are common ways to do this and solve these problems. So now, if your student needs more help or you need more help with algebra, then the best place for this would be our Algebra 1 program, which uses Harold Jacobs' algebra textbook. And again, this is out of chapter 7 that goes through simultaneous equations. What we're talking about here is one of the lessons in there. This is also in the geometry course, but that's a review, right? You should be reviewing it at that point because that's what it's called, and it is an algebra review. In Algebra 2 with Trig, they go back over this again in, I think it's chapter 2, where we're reviewing it. So we'll put links to those in the notes for you to take a look at if you're needing more help with this and getting stronger in your algebra to get more lessons on this and get problems to work.